is a node, that means 4 minutes, right?
Correct. So, yeah, this is Steven Villa from LMU Munich. So from the earlier presentations in this session, we've seen how relevant it is to measure user mood and emotional state. And in this presentation, I want to pose a slightly different perspective. That is, how do we communicate unobtrusively these emotions to different users, for example? And when we think about presenting information unobtrusively, haptics comes as a highly plausible method to do it. And as in the daily life, we already are using haptics for example, a smartwatch or to explore objects. We decided to move a bit away from this region, and we decided to explore the dorsal region that is less likely to be occluded by other type of informations. So the question in here was how vibrotactile features correlate to the 4 basic emotions in the dorsal region. And with the basic emotions, I refer to anger, happiness, sadness, and a neutral emotion. So we developed a prototype with 6 linear actuators in order to explore this, and we evaluated this in a user study with 40 participants with between subject designs, where we induce the target emotions to every participant and then ask them to generate a set of patterns. So the interesting part in here regarding amplitude and frequency is that, for example, for the angry emotions, we found that participants tended to report higher frequencies and intensities in the middle and lower part of the back, while for the happiness sensation, the happiness emotion, this was more pronounced in the middle part. For the neutral, this was more balanced, but still we saw some higher frequencies in the top part, and the sad emotion was closely similar to the anger one, but with lower intensity and frequency in general. But what is important right here is that with the intensity alone, we can differentiate the 4 basic emotions. But when it comes to frequency, it is mostly useful to differentiate between anger and the rest of emotions. Regarding to the spatial locations, we found 2 very interesting insights. One is that we found that the patterns were in general symmetrical. This is that all the actuators had a correspondence between left and right, which already provides some insight in how to design these devices next. Also, something interesting in here is that the top and bottom part were the most descriptive, as they had the higher difference in patterns. Now, coming for the feature relevance, we can already provide some design recommendations. In here is quite clear that intensity is the main feature, as it can describe all these emotions alone. And frequency is helpful as a complementary feature, but is especially good when we want to render anger. And in terms of the spatial location, it can be complementary, but still, if we focus more in the 2 first one, we will have already a quite descriptive way of rendering emotions in the dorsal region. So, yeah, this is it by now, and I will be happy to take any questions.
While you wait for a question, can I ask the authors to go over there? Any question for him?
Just curious whether there any literature that talk about the physiological basis for this observation.
Sorry, who you?
Like why that's the case, this kind of spatial location correlating with mood.
So this answer specifically, I don't have. The idea with this work was to find what are these implicit correlations that people will have by describing one emotion to, for example, this feature of a spatial location, but also with intensity. For intensity, we know that people already take some analogies from smartphones and so on, but for the back is less clear, and we wanted actually to explore what will be this type of correlation, like lower or higher will have some implications for example, happiness or sadness. Yeah, I hope this responded to the question. So, she asked why the dorsal region, and then the answer for this is that as we want to communicate information in addition to the visual and auditory channels, this is generally not used for other type of information. So of course, when we see it, we have some tactile information, but this is not complex information that we're gonna use for something else. So this was an area that we selected that is kind of big, so we can encode more data in there, and it's also not occluding with other type of information. Yeah.
There was a question on the chat, and thank you whoever asked that, how the vibrotactile patterns are designed.
So they are not designed. There are some approaches that already take some analogies from visual, for example, and then they try to move them to vibrotactile. But what we did was inducing the emotional state to the participants, and then we asked them to represent this emotional state with vibrotactile patterns. So this was user-generated.
So we have around 15 minutes to be able to engage with them, ask questions. There are a microphone over there if you want to line up. And I can probably get started just to be able to think out loud. And there is somebody online, right? Kun Liang, can you hear us?